DB Creations, which actually I don't know the full backstory behind your name. Is it short for Dustin Blake?
That's
okay.
Right.
DB Creations. So these are two of my favorite devs, all Seattleites as well. Anyone else from Seattle in the room? Anybody? Anybody? There we go. That's right. Man, we first connected in my previous life, back when I was with Tilt 5. I think you guys had reached out to me and said, hey, we got some cool game ideas. We want to figure out how to work, in AR. I don't know if you'll talk much about this background, so I will. I love how kind of like cross-platform minded your team is. Kind of like AR first thinking. There's a lot of studios you'll see that like they come with different backgrounds. Okay, we do console gaming, we do PC gaming. Now we're looking at AR as a way to complement that. This is one of the few studios that I've met that's kind of like AR first, looking at glasses, like wearable type experiences, mobile AR type experiences. How do those make sense? But then also kind of crafting your own unique IP that can like work across all of these different platforms. So give it up for these guys. Love this team. Go, Blake.
Well, Thank you, Joe. Hi, everyone. Isn't Joe just wonderful? Every time I see him, he just makes me so happy. All right, so today we're going to be talking about a specific prototype we built last summer. You can tell it's summer in Seattle because the sun's out. Around a prototype we did to think about what would it look like to have the entire park as your map in an AR game. I'm Blake Gross, and on the slide is my business partner, Dustin. You can see here. We run a small game studio based out of Bellevue, Washington. It's fully remote. We have about 4 full-time employees and 6 contractors. And together, like Joe mentioned, we make a bunch of different AR games, all using our own IP. This is a few of them that we've released so far this year. Table Towers is a solar punk city builder where you basically can use your living room as the map to create your city and stuff connects, and there's helicopters that spawn and stuff. And then Table Choppers is a arcadey helicopter game where you pick up crates really quickly, as fast as you can within the time limit, to see if you can get the high score, and the crates kind of actually spawn in the real world. Most of our work so far has been on the Snapchat platform, where we've had about 3 million users playing our games. But today I'm here to talk about our strategy series of games that we've called Table Trenches. The original Table Trenches was built for iOS and Android using ARKit and AR Core. We released that back in 2020. At the time, really, the only capability that existed was single plane tracking, and so that's what the game was built around, was conforming to an actual single plane scan and trying to fit the dimensions of that table. All of our games in this space have really been about trying to think about how do we use the world as the map, and we've always felt that strategy games work really well for that because you can have the units actually conform to the around the objects in the real world. So that was really the inspiration behind the sequel, the follow-up to Table Trenches, Operation Living Room, which we released on the Snapchat platform last year. In this game, we use world meshing and multi-surface detection to actually conform the play space to multiple surfaces and have it so that units will actually traverse over changes in variable terrain. And we actually won an award for this game, Lens of the Year Play, at the Snapchat Lens Fest Awards last year. Thank you. And then this all inspired us to want to think about how do we take these strategy games and apply the concepts that we've built to an entire park. And so this is some concept art we made around thinking about what a park scale strategy game looks like. So the prototype that we then set out to make was to make this concept art real on an actual phone so that we could see what it would look like at scale and start to understand some of the challenges in trying to actually build a park scale game. The park we chose is actually one very familiar to Niantic because their offices are right next door. It's the downtown Bellevue Park. It was also very convenient for me because I could just bike down to it. And then when we wanted to show Niantic what we were working on, we could just have them come on over. So the first thing we did was we scanned the VPS waypoint, made a private waypoint next to the place the concept art photo was taken. And so this worked really well because this could act as our central localization point for our experience. However, the scan is a lot smaller than the total amount of space that we needed in order to show off what our concept art was trying to show with the park experience. So then we got to working on figuring out how do we create a better scanning setup. This took a couple iterations of trying to figure out what do we do. The core tech we used was Niantic Scaniverse, like you heard about in the last presentation. But what we found is that it's a lot easier to scan when the phone is at a higher angle, because the wider FOV you get, the quicker that you can actually scan everything. So the way to achieve this was we mounted it on a tripod, but then no longer could see the screen. So we hooked it up to a pair of Nreal Air AR glasses, hooked that up to our laptop, and then I had this fun rig that I was walking around with, and I got a lot of weird looks. But I wore my Niantic Lightship shirt, so they thought that maybe I was an employee or something and complained to Niantic. So we were able to, after a few attempts, take this scan of the basic effective area from the concept. However, as you can see, that's only a small part of the entire Bellevue Park. This took about 30 minutes to do. And you can see that I even missed a few spots. I missed a few spots because a dog was stealing someone's lunch and ate it all. And people were getting into a fight over it. And I was like, I'm not getting near them. So if we wanted to scan the entire park, we would obviously take a couple more hours. We'd probably actually need a couple people with kits and then have to composite it all together in the end. Now that we had the full scan, it was time to take that into Unity and align all of our content to it. The original prototype was kind of kit bashed together with assets from the original table trenches. So we took those assets, we already had them Unity ready, aligned them to the scene, and then we created VFX to match what was in the concept art. This was all then using the Unity timeline so that we could easily create a small loop that was all real time that we could have in our experience. So then after that, I went to make the park my office for the day. Something wonderful about Bellevue Park is it has Wi-Fi, so it's actually very easy to work from. I'm not sure if that's very common for parks. I also got a lot of weird looks this day because it was one of the few sunny days in Seattle, and I was outside working on a laptop. Now, at the time, doing actual content alignment wasn't super easy because there wasn't any in-editor support, so I had to create a custom application to do this. What this is doing is it's using screen space raycast hitting to the world mesh in order to align the content, and then I have a custom debug transform hierarchy so that I can set the manual translation and rotation offsets so that I can get the content actually aligned to the VPS waypoint. Once that was all set up and all the alignment was done, it took about an afternoon, we had a full application that we had on iOS and Android so that people would be able to view the experience. So the first thing that users have to do when using this is localize against the VPS waypoint. This then synchronizes all of the content and then loads in our cached meshes. One of the cool things was that it was actually really awesome to see everything at scale on an actual mobile device. You can see that the tower is kind of like towering over you. And then something else that we had was the debug view to be able to see the actual meshes that we were using in the experience. So here the blue represents the VPS mesh that we were able to load. That's all cached locally. And then we also had this gray mesh, which represents the mesh that we took with Scaniverse. What was nice about this is this allowed us to make sure that everything was actually properly occluded. Now, something to keep in mind when building any type of experience that's actually anchored to a real location is that the anchor points need to be stored somewhere. So here, part of the custom editor application was creating a serialized anchor around the VPS waypoint, and then uploading that to the Google Cloud store so that client devices could then pull that down whenever they were using Experience so that the content would load correctly. Something else we were interested in while building this experience was thinking about remote scenarios. This was from a few different angles. One of them was kind of a remote viewer scenario. We imagined that this was kind of a full game, that there would be a desire to see kind of what was going on in an immersive way, as well as we thought a lot about kind of a multimodal approach where it didn't matter if you were at the park or you're at home or you're on a bus. We wanted everyone to be able to play the game and use the park as the map no matter what. So this is the tabletop experience. This is where the Scaniverse mesh really came in handy, where you're able to load that on the table, have the player positioned around, and then see the kind of full experience we built at a miniature scale. With the idea being that if this was a full game, there'd be some type of live streaming aspect to what was going on. We also want to experiment with different types of visualization techniques. So in addition to the LiDAR mesh, we also did photogrammetry. And then this is a nerf capture, a neural radiance field. Basically, what this is taking a bunch of photos and putting it through a custom neural network algorithm in order to produce this, I think it's basically like 2D billboarded point cloud thing. What was really cool about it, though, we could have done more iteration, cleaned up a bit, but you can see the water is actually reflective and shown, and this is something that is hard to get normally with other techniques. And so that was cool to be able to see that detail filled in. It's also high res, and since we actually started working on this, people have gotten NeRFs rendering really effectively on mobile, so it's definitely an interesting area to continue investigating. In terms of Lightship features we used, the blimps were all using sky segmentation. This was super nice because they would only show up in the sky, but it also meant that we got like really perfect occlusion, because whether it was a city building behind it or a tree, the blimp looked like it was where it was supposed to be. When the new map SDK came out, we actually were using Mapbox. We switched it out for the new map SDK so that the users could actually see where our experience was on the map at Bellevue Park. And then we used screen space ray hitting to be able to actually determine where to place your experience, as well as when we were building our editor application. And then both the tabletop experience as well as the in-world experience at the park uses the occlusion tech, which is really nice because it works on both non-LiDAR and LiDAR devices. In terms of next steps, well, like I said, we'd really like to do a full park scan to see what that would be like and try to figure out what the fidelity of that would be. This prototype was really only trying to show off what the visuals of the experience would be and get a sense of the scale at the space and figure out some of the initial technological challenges. So going forward with a full game prototype would be interesting. One of the big challenges with pitching a game like this is that it's a lot of work to just get one park up and running. We do think that we'd want to do that manual work for what we call like hero parks, larger parks in major metropolitan areas, but we'd want to support every park. So we wanted to figure out automatic ways to be able to make sure that that content worked. We also had some ideas around using scanning APIs in the background to try to construct that as users were around those areas. Additionally, we wanted to customize our scanning application more after using it. We really wanted editor functionality, in addition to the ability to set bounds so that we could see like, oh, I want to cover this area with my actual scan, and then the user who's using the scanning can see when they're complete and how much more they have to go. And then finally, we think that these kind of custom experiences like this are actually really cool, but downloading a dedicated application is a lot of work and a lot of ask for people. So we'd love to port this to 8th Wall, and we actually think that will be a great home for things like this when you don't actually have to fully download an application. And then if there was like a client experience to show where location-based experiences are, that would really kind of add to that. Thank you, and I'll now take any questions.